In this video, we are going to discuss a very interesting problem of mathematics. This question was asked in IIT JEE Entrance Exam, which is considered one of the most difficult engineering entrance exams in the world. We have to compare these two values and we have to tell which value is greater, whether e raised to power pi is greater value or pi raised to power e is greater value. That is what we have to determine in this question. The concept that I will discuss in this video can be used to compare other similar values also. Suppose we have to compare these two values, whether 2019 raised to power 2020 is greater or 2020 raised to power 2019 is greater. Or we have to compare these two values, 5 by 3 raised to power 3 by 5 and 7 by 4 raised to power 4 by 7. So these are very interesting looking expressions of mathematics. So if we have to compare these expressions, how we will do it, that we will understand in this video. Welcome back everyone to my channel MathMantis. To continue supporting me in making more of these maths interesting videos, please give this video a thumbs up and subscribe to my YouTube channel. Now let us get back to the original question and understand the concept behind the solution. Now in order to compare these two values, what will I do is I will compare these two values, e raised to power 1 by e and pi raised to power 1 by pi. Suppose this value is greater than this value. Now if you will take the whole power both sides is pi multiplied by e, you will get this expression only because pi e will multiplied by 1 by e. Here the power will become nothing but pi. Here these two powers will multiplied, here the power will become nothing but e. So if we are able to compare these two values, then we can easily compare these two values also. So that is the thought process behind it. So now to compare these two values, what will I do is I will consider a function x raised to power 1 by x. Now in the next step, what I will do is I will analyze the behavior of this function. To analyze the behavior, that is the increasing and decreasing behavior of this function, I will differentiate this function both the sides with respect to x. To differentiate both the sides with respect to x, one of the ways is you can take logarithm both the sides and differentiate like this, that you can write ln y equal to right side expression is ln x raised to power 1 by x. Then you can use the property of logarithm, you can bring this value in front, that is the power property of log. You can write this expression as 1 by x ln x. Then you can differentiate both the sides with respect to x. That is the one way to find dy by dx, that is the derivative of the function. I will use another way to find the derivative of this function. To do that, what I will do is I will rewrite this expression as e raised to the power 1 by x ln x. Now how did I do that? Let me explain you. To do that, we will understand the properties of logarithm. The first property of the logarithm is the power property of the logarithm. That in a log expression, if there is an argument and there is a power to the argument, you can bring that power to the front. This is the same property we will use here. So to do this, we will rewrite this expression as 1 by x, we can bring it to the power x. So here we can write this expression as e raised to the power ln x raised to power 1 by x. This is the property I have used here. Now the next property of logarithm we have used here is this one. A raised to the power log to the base a, b is equal to b. So the condition is here the base is a and in exponent the logarithm term base is also a. If this is the case, the same base here and same base here. So you can remove whole this expression and write this value as b. This is the basic idea of this property. So in this expression, how we can apply this property is, we know ln we can write as log to the base e. So you can see the base here is also e, here base is also e. So we can remove this whole part, we can write this expression as b, that is x raised to power 1 by x. That is the only thing I have written here. So we have understood now why this expression is similar to this expression using properties of logarithm. But let me tell you the fastest way in which I have written this expression. X raised to the power 1 by x is equal to e raised to the power 1 by x ln x. The fastest way is if there is an expression like this, a raised to the power b. And if you have to write this expression such that this base a should not be the base, it should be in the exponent. So the way to write it as, if you will bring the a to exponent, it will change to the log a. This is the way to write this expression. Remember, the base of logarithm is e only, and the base of logarithm, if it is e, In the base part, you will write this as e. This is the way to write this expression in the fastest possible way. The same thing I have applied there. I have bring this value x to the exponent, that will change to log x. In place of x, the value will become e. This is the fastest way to write this expression like this. So now the first part is complete, that we have changed to this value. Why did I do this? Because in the next part, when will I have to differentiate both the sides with respect to x to find dy by dx, it will become very easier for me to differentiate this expression. To differentiate this expression, first what I will do is, I will differentiate e raised to the power, because I have to apply chain rule. It is not e raised to power x, it is e raised to the power fx. So the first value that will come out to be e raised to the power fx. This is the value that will come. Now in the next step, what we will do is, we will multiply this expression by differentiation of this power. For differentiation of this power value, this function value, we will apply the product rule of the differentiation. In the product rule of the differentiation, first we will differentiate 1 by x, that will be minus 1 by x square multiplied by the second function, plus 1 by x multiplied by ln x derivative, that is 1 by x. So this is the derivative of x raised to the power 1 by x. In the next step, I will create the factors. I can see that here also the value is 1 by x square, here also the value is 1 by x square. I will take 1 by x square common. So inside it will become 1 minus ln x. Now I will find the values of x where derivative is 0, so that you will be able to determine where the function is increasing and decreasing. But before doing that, let's find the factors which are always positive. So if you will look at this expression is always positive, because 1 by x square is also positive, e raised to the power any value is also positive. So when we will equate this to 0, you will get only the value of x for which this expression can be 0 when ln x is equal to 1, and that is only possible when x is equal to e. So that is the critical point of this function. Now in the next step, I will mark this point on the number line and I will analyze the sign of the derivative dy by dx. At this value of x, the derivative value is nothing but equal to 0. So to the either side of this, the derivative sign will change. This value is always positive, so the sign will change of only this value. If you will increase the value of x beyond e, it will become ln 4, ln 5 like this. So this value will become greater than 1. So the whole sign will become negative. So the derivative sign here is negative. And beyond e, if you decrease the value, ln value will become lesser than 1. So this value is always positive. So the derivative sign will become positive, because positive multiplied by positive is always positive. Now based on that, we can analyze the behavior of the function x raised to power 1 by x, that is the value of y. If the derivative sign is positive, we can say that from here till e, the value of y is always increasing. So this is how we represent that value. And after the value of x equal to e, the value of y will always decrease. So now this is the behavior of function y. Now let's move on to the next and the final step. We can see that for x equal to e, the value of function x raised to the power 1 by x is largest value. That means e raised to the power 1 by e is the largest value there possible. And if you will consider the value of x equal to pi, pi is nothing but 3.14. Obviously that value is greater than e, so that value will come out to be here. For this value of x, if you will see, the value of y will be smaller than that of value at x equal to e. So we can see that the value is decreasing, so the value is smaller. So we can compare these two values. E raised to power 1 by is always greater than pi raised to power 1 by pi from the behavior of this function. So we can take both the sides power pi e. We can say that e raised to power pi is greater than pi raised to power e. So in this way, we have determined which value is greater. In a similar way, other question of mathematics can also be created. Suppose we consider two values of x, 2019, 2020. We can see that at x equal to 2019, the value is larger. At x equal to 2020, the value is smaller. So now we can compare these two values also. 2019 raised to power 1 by 2019, 2020 raised to power 1 by 2020. We have just put here the value of x 2019 and 2020. Now similar to the previous expression, e raised to power pi and pi raised to power e, we can say that 2019 raised to power 2020 is greater than 2020 raised to power 2019. We can compare these two values also. But now let me tell you one more interesting thing about this function, that is x raised to power 1 by x. For this, x equal to 0 is also very important because the domain of this function is defined as for all real values of x greater than 0. So this is also an important point. And based on this, new questions can also be framed if we consider two values between 0 to e. So on right side of e, if you will see the value of x, it will increase, the value of y will decrease. But between 0 to e, if you will consider two values such that the value of x is increasing, the value of y is also increasing. Let us consider two values of x between 0 to e as 5 by 3 and 7 by 4. So we can say that at the value of x equal to 5 by 3, the value is smaller of y. At 7 by 4, the value is larger. So we can say that for 7 by 4 raised to power 1 by 7 by 4, that value is greater than 5 by 3 raised to power 1 upon 5 by 3, which can be simplified as like this also. 5 by 3 raised to power 3 by 5 is less than 7 by 4 raised to power 4 by 7. So this type of question can also be solved. So this is a very important function, x raised to power 1 by x. For this, the important critical point is x equal to e, where the value of the function is the largest. After e, the value of function starts decreasing, and if you will take out the values of x before e, as the value of x is increasing, the value of function is also increasing. So this function is very important, x raised to the power 1 by x. If you see this type of expression, same power here also, even if in reciprocal, or if you will see the expression like e raised to power pi raised to power e. So if you will see the expression like this, a raised to the power b, b raised to the power a. So you will be able to understand that you have to apply the property of this function. That is the behavior of this function. So that is a very important concept we have covered in this video. Thank you so much for watching this video, and I will see you in the next video.